This is Bangladesh. It's next to India. It has beaches, it has mangrove forests, it has Bengal tigers. This is Dhaka, the capital. It's crowded, like really crowded. 4 times New York City crowded. And here's the thing, the city can't support all these people. It doesn't have modern water treatment. This creates a problem. Poop.
So think about it. We've got 30,000 people per square kilometer pooping, and there's no sewage treatment plant.
That's Steve Luby, an infectious disease doctor. He lived in Dhaka for 8 years. Now he works at Stanford.
So the basic problem with untreated water is the water has poop in it. And there's just a whole lot of germs that live in poop that then can go from person to person.
Those germs create a major health problem.
Every day around the world, about 2,000 children die from diarrheal disease.
That's Jenna Davis. She works with Steve at Stanford.
In the United States and other wealthier countries, we've largely solved this problem.
How? Huge, expensive water treatment plants. Dhaka can't afford them. If residents want clean water, they have to clean it themselves. This is Amy. She's an engineer who specializes in global sanitation and safe water. Steve asked Amy to come up with a better, easier, cheaper way to provide clean water to Dhaka.
So there are a variety of ways that you can disinfect water.
You can use a filter. You can boil it. You can use UV light.
We knew that we wanted to use chlorine.
Right, the stuff in bleach.
It's extremely effective at killing both bacteria and viruses and all types of pathogens, and it's very low cost to purchase.
Great, chlorine. But with no treatment plants, how are they going to add chlorine to the water for millions of people? Amy packed her suitcase and headed to Dhaka to learn more.
Something that really stood out was that people were using manual hand pumps to extract water from the pipe system.
This gave Amy an idea.
We needed a technology that could be compatible with these manual hand pumps. We couldn't find any technologies that would be appropriate in Dhaka.
So Amy packed a 70-pound hand pump in her suitcase and brought it to her lab at Stanford. The challenge? Develop a way to clean water directly from the pump.
For the first few years, we were able to prototype and test all different types of devices that we thought might work.
Their hard work paid off, and they came up with a solution.
So this is the Venturi system.
Fred's an engineering grad student who works on the project. He'll explain how the device works.
So we have a chlorine reservoir at the top that holds all the disinfectant. From there, it feeds the chlorine into an intermediate tank.
The chlorine stays here until the water starts pumping. Fred's dyeing the chlorine pink to show its movement.
It gets fed into what we call the Venturi.
That's this thing. It's super important. The shape of the Venturi causes a pressure difference,
which leads to chlorine being sucked in to the water stream.
The shape of the Venturi influences how much chlorine is added to the water. They had the design down, but they still had to test it and tweak it along the way.
Our field testing in Dhaka required us to make a lot of iterations and modifications to the device.
They test things like chlorine and bacteria levels to make sure enough chlorine gets sucked into the water to actually kill the bacteria.
One tool that's really allowed us to iterate quickly is a 3D printer.
Yeah, that's right. They can actually 3D print this thing in Bangladesh. Okay, let's recap. Simple device, attaches to hand pump, sucks in chlorine, kills germs. I'm sold.
We have it to the point where we basically have proof of concept that it can work well in the field in Dhaka.
They've nailed the science. Now it's just a matter of business to get these things up and running.
What we want to see is this technology being scaled up and distributed throughout the world.